This first here is common root rot, which is caused by the fungus Cochleobolus sativus, also referred to as bipolaris or also Helminthiasporium, depends on what stage that you see. And here in this first picture is a pure culture growing, and it's kind of hard to see, but if you see all these really dense black specks all around the plate, that's actually the conidia of the fungus. And that conidia and the mycelium overwinters in the soil and also on crop residues. And then in the spring, those the mycelium and spores can infect the young seedlings. And throughout the season, this will lead to these necrotic lesions on the roots, the subcrown, and also the crown. So overall, throughout the growing season, it ends up causing some reduced root growth, also reduces tillering, and causes stunting and early maturation, which obviously leads to reduced yields. And then also this pathogen can cause secondary conidia can be produced to also cause tan spot in wheat as well. The other disease that we wanted to look at was Fusarium crown rot, and there's actually several species involved with Fusarium crown rot, but one of the most common is Fusarium graminearum, and this is shown here in the first photo as well. And it's pretty similar. The life cycle is pretty similar, where it overwinters in soil and crop residue and also infects young seedlings. And as we go throughout the season, it ends up creating these dark brown lesions on the nodes. And also it restricts the vascular bundles, which leads to reduced water and nutrient uptake. And also secondary conidia of this fungus can cause Fusarium head blight as well. So all in all, both of these pathogens, they cause root rots in wheat, and they're also widely distributed. They're found in almost any wheat growing region across the world. And both of them primarily persist on infected residue, but they can also survive for months if that host is not available. And in wheat and barley, both of these pathogens are often found together on infected plants. And typically warm to dry conditions are conducive for disease development. So with that said, water stress can really increase the severity of these diseases. And they can become major issues during drought years as well. And like I had mentioned, losses really result from thin stands and stunting and decreased tiller number. And yield losses are generally around 10%. It kind of goes unnoticed. But under severe conditions, you can have yield losses up to 30%. So managing these root rots can be done through several cultural and mechanical practices, just such as crop rotation or conventional tillage to reduce that inoculum going into the season. You can also have some plant partially resistant varieties. I don't think there's really any fully resistant varieties out there. So fungicide seed treatments can also allow for an early window of protection for these diseases. So Andrew Friskop, back in, maybe this is data from about 2 years ago, he took a data set of 46 experiments from 2003 to 2020, and he looked at the average stand response. So you can see generally we saw improved stands when using a seed treatment. Sometimes we did see some negative impacts, and presumably those are in super dry conditions or unfavorable environments. So 72% of those data points were positive, where we saw improved stands when comparing seed treatment to non-treated seed. But it was noted that it's difficult to have a corresponding yield. So yeah, you might have better stand, but it doesn't always mean that you're going to have a better yield. So kind of changing gears here, I just want to talk about subsurface drainage. So in many parts of the Red River Valley, especially here in the Red River Valley, there's some soils with a really high clay content, and they seem to really benefit from improved drainage. And that just decreases the risk of waterlogged soils. So a well-designed drainage system can reduce surface runoff, can help reduce flooding in low areas, and also simply allow for more timely field operations. But doing this also allows for conditions where we have warmer soils. We also improve the soil aeration and soil structure, and ultimately we provide a more conducive environment for root growth and then higher yields and improved crop quality. So moving to why were we interested in doing this trial, right? So we have a pretty general understanding of the environments that are conducive for disease development, but the information on the interactions between drainage and the interactions between root diseases and the impact of those seed treatments in these drain conditions is really lacking. We don't really have that information, right? So growers really need to accurately evaluate the cost of drainage. So for growers to accurately evaluate the cost of drainage systems and its potential benefits for wheat production, we kind of need to get an understanding of what, if you do drainage, what's going to happen to our seed treatments, what's going to happen to these root rot diseases. So we have this kind of a pretty large trial site established here in Crookston. We have 4 individual sites, probably about a half an acre each allowing for this 4-year crop rotation. So this year wheat was preceded by dry beans last year in this soil site. And the research plot area was actually established back in 2001 on a Hagney silty clay soil, which is classified as a poorly drained soil. And then when they installed this subsurface drainage, it was randomly assigned. So that's why we see we have 15 feet, 60, 25, 40, then a non-drained site way down on the south end. And those were put in at a depth of 40 inches. Here we go. So yeah, that's just kind of an illustration. It's really not to scale. So those are those 4 sites. Those drainage spacings are going across all of those sites there. So here's kind of a picture of that area, and in the background here, we're actually inoculating the ground with some of the pathogens that we were growing artificially. So we were able to get in at May 3rd this year. We planted the Minnesota Torgay variety, and I think, Mike, this was our first trial planted, maybe. So anyways, it just kind of goes to show, it allows for more timely field operations. This was pretty average across the valley, but it was nice to get into this site a little before some of the other ones. And this year, so once we planted, we planted straight north and south, and then we came through and we cut 20-foot long plots. And then we had 8 replicates of those 20-foot long plots with a seed treatment or a non-treated seed. Our seed treatment that we used was the Stamina F4 cereals, and unfortunately I have to do that by hand in 5-pound batches, which is not necessarily too fun. And then the other seed, or non-treated seed, is just purely bare seed that we put in the ground. But before we do planting, like I mentioned, we grew out Fusarium, Graminearum, and Cochleobolus on sterilized grains, and that way we can spread it out into the field. And so one thing that we did differently this year was substantially increase that inoculation rate, hoping to get a little bit more disease incidence in the field trial to really see that impact. So here's a picture of our little planter going down. And, there was some other differences this year. So 2023, if you think back to 2022, we had that really bad flooding early on, really pushed us to kind of have a later planting date. So once again, it was pretty nice to get into the field. We had an average planting date. We got in when there was some pretty good soil moisture as well early in the season. But the remainder of the growing season was much drier than the 30-year average. I think less than half of the rain that we normally received. And also we had some temperatures that were fairly above average for May and June, and then it cooled down and we had temperatures below average for July. So, once again, kind of some different environments moving through the season. So here you can see this is just a simple graph of soil moisture that was collected on the top. You can see the soil moisture kind of going up and down, and here is our rainfall data for Crookston. So I just want to show, we have that general trend where we receive rain and obviously soil moisture goes up. But now moving on, we actually have data for all of our drain spacing. And you can see there are some differences, but there's really no significant differences between those drain spacings moving throughout the season. Once again, we were very, very dry. I think if we had a season where we were experiencing excessive rainfall, we would really see that difference where, once again, we're decreasing the risk of waterlogged soils and that flooding on the top part of the soil. And also when you average all that season-long soil moisture, we don't necessarily see a difference between those drain spacings, at least here in 2023. So moving on, about 2 weeks after planting, we went out and we actually started doing stand counts. We want to see, well, is there an impact of that seed treatment once again, or soil moisture? So we went out and we did stand counts, and it was an average of 1.35 million plants per acre, so we kind of hit right on our target there. You can see a very, very slight difference between the seed treatment and the non-treated control. Once again, it was a little drier this year, but that difference is really not big. And looking at all of our drain spacing treatments, once again, we see some very, very slight differences, but all in all, very similar stands throughout all of the treatments that we had. And then moving forward, I don't know if anybody has had to do stand counts with wheat, but it does get very difficult. So instead, we chose to go forward with just taking digital photographs, and we have a program. And we changed this year. I've been using a program called Assess 2.0. It's really neat. You can take a photo, upload it onto the computer, and it'll tell you how much green coverage there is compared to the black dirt. And if you're really, really good with the program, you can kind of eliminate some of the weed seeds and some other things in between the rows, for the most part. And through the past couple of years, we've had really good luck with this, and it's an indirect way of taking into account plant stands, overall tillerine, and just canopy coverage or ground coverage in general. So it gives you a really good picture. And moving throughout the season, actually right away we did see that small difference between the non-treated seed and the seed treatment, but I think it was 5% ground coverage compared to 5.2%. So really nothing major there. But when we look at the drain spacings, this is where we start to see significant differences. And when we get to June 12th here, 40 days after planting, we start to see some pretty significant differences. So when I break that out in between all of the treatments that we had, you can see the 15 and the 25-foot drain spacing overall had the highest ground coverage, so there was more green growth there. And it was significantly more than the 60-foot drain spacing and the non-drained area. And what's really interesting here is even though it's not significant, you can see this trend here where the non-treated control is doing better at the more drained areas, but as we move to the non-drained areas, that's when our seed treatment is actually doing better than the non-treated control. So just kind of an interesting observation at this point. And then moving forward, this year we were actually able to do some ratings and some platings for disease. So, increasing that inoculum rate, we were able to see a little bit more disease out there. And so this was done on July 14th. So at this point, we still had some kind of green growth. It was just about to start to dry down. And you could start to see that early maturing plants, and they kind of show up as these white heads. So we were able to go through and kind of do estimate how many plants were showing symptoms, these above ground symptoms. And this was done with Joachim Wiersma. He really helped me with this part of the project. And so we went through, we rated, each of those 20-foot plots, we rated once every 5 feet. And then we started pulling up plants to make sure that, yes, it was actually common root rot or Fusarium crown rot. And yeah, some of them actually were some sawfly damage. So these ratings here, so it was only about 1.5% of plants out there were showing these symptoms pretty dramatically. And then 10% of those actually seemed to be caused by sawfly, just those white heads that would be pulled up. But really when you're looking at that, a 1.5% incidence compared to a 1.7% incidence, a slight difference, but that is a very small number still. So even though we increased that inoculation rate, we really didn't see a lot of disease out there this year. And there is some differences between the drain spacing, but really nothing significant. And then we were able to take all of those roots, we actually brought them back into the lab. We did some surface sterilization and plated them out onto artificial media again. And I went through and identified underneath a microscope what could be causing that. And what we saw was about 36% of the roots had cochleobolus growing from them, 38% had Fusarium growing from them, and actually there was 2% that I found Rhizoctonia growing from the roots as well. The other 10%, you just had kind of some contamination that came in, and it was very difficult to identify what was causing it. But let's just round up. Let's just say half was caused by cochleobolus, half was caused by Fusarium. And then finally, we get to our yield data, and this year was another absolutely phenomenal year. We averaged 104.5 bushels per acre in this area. You can see there's really no difference at all between the seed treatment and the non-treated seed. But when we look at that drain spacing, we see that all of our drain spacing, provided us with almost a 10 bushel increase compared to our non-drain soil this year. So that was really interesting to see this year. And with that 15-foot providing the highest yield, and it kind of corresponds with that canopy growth estimate that we took way earlier in June. So with that, there was slight differences that we saw between seed treatments for root rot severity, but not really for growth progress or yield. But we did actually see some pretty significant differences between those drain spacings, especially for growth progress and especially for yield. And then there were some slight differences for root rot severity, but really nothing significant in terms of disease. So with that, I would just like to thank everybody. Thank you, the Minnesota Wheat Research and Promotion Council, for funding. Thank you for the Northwest Research and Outreach Center for all of the land and equipment. Thank you for the technical support team, the sugar beet pathology crew, and also the soil science crew with all the data collection that we did. So with that, if I have any time, I'd love to take any questions.